Alright, welcome back to our next video lecture. This is section 5.5, which is paired together in the homework with section 4.4. Section 5.5 covers the mean value theorem for integrals, and we're just going to use that to calculate the average value. What the mean value theorem for integrals says is that there's some c value, again in this a to b interval, such that f of c is equal to 1 over b minus a times the integral from a to b of f of x dx. In other words, this says that there is some number in a to b such that f of c is equal to f av, which is the average value from a to b. Go ahead and skip ahead to take a look at example on the second page. Let's explain what f average is geometrically. So, let's say we have some function right here, f of x. And let's imagine that this function is made of a block of ice, and we're going to put it in a bin right here. And then let's say that block of ice melted, and whatever the value of that function is when it's melted is going to be the average value. So you can imagine here that this ice would melt down and fill that thing. So what we're saying is that the integral from a to b of f of x dx, that's our ice block, this is equal to this rectangle right here, this green rectangle that we have filled in by the average value. So what's the area of that rectangle? Well, it's the average value times b minus a, because this is the height of the rectangle and b minus a is the width of the rectangle. Now, what happens if we divide b minus a over to the other side? Well, we get the integral from a to b of f of x dx divided by b minus a is equal to the average value of f. And we can rewrite this just a little bit to get that original formula. Division by b minus a is the same as multiplication by 1 over b minus a. And then we have the integral from a to b of f of x dx is equal to f av, and that is exactly the formula that we had at the beginning. So this is a geometric representation of what the average value is. Now let's just take a look at a couple of examples, and that's all we're going to do in this lecture video because there's just the 3 web work problems at the end of the 4.4, 5.5 web work, and they're only having you calculate the average value. So we're not going to do it graphically there, we're just going to do these examples here. So let's take a look at example 9. We want to find the average value of f of x on the interval from 1 to 5. So in this case, f av is equal to 1 over 5 minus 1. We get that 5 minus 1 from our a and our b value in our interval. And then we're going to take the integral from 1 to 5 of x dx. Now when we do this calculation, we get 1 over 4 times x squared over 2 evaluated from 1 to 5 because we're evaluating our definite integral there. So we have 1/4 times 25 over 2 minus 1 over 2, which is equal to 1/4 times 24 over 2, which is 1/4 times 12, which is 3. So our average value of f of x equals x for 1 to 5 is 3. And that makes sense because that's just a linear function from 1 to 5, and the average value there, 3 is the midpoint, so that is the average value. Let's go ahead and do this for a trig function. So we're going to do the exact same thing. Our g av, since our function is g in this case, is going to be 1 over pi minus pi over 6. That is our a and our b value in there, times the integral from pi over 6 to pi of the sine of t dt. And when we find this integral, we're going to get, so we have 1 divided by 5 pi over 6, and then we have the antiderivative of sine is negative cosine. We're going to be evaluating this from pi over 6 to pi. Note that a lot of people here would get cosine. as the antiderivative, because cosine is the derivative of sine, but remember we're going backwards, we're finding the antiderivative. So we have 1 divided by 5 pi over 6. We can flip that and multiply. So we have 6 over 5 pi. And then we're going to go ahead and evaluate our antiderivative, negative cosine of t at pi. And then we're going to subtract negative cosine of pi over 6. And when we simplify this, we get 6 over 5 pi times negative 1, that's the value of cosine at pi, minus the cosine of pi over 6 is root 3 over 2. And so if we simplify that one step farther, we have 6 over 5 pi times 1 plus root 3 over 2. And that is our average value on this interval. Now, let's go and take a look at the last 2 examples in this packet that are the most similar to the examples that you'll be looking at in web work. So first, let's find the average value from 0 to 3. That's going to be 1, let's say we're going to find f_av. That's 1 over 3 minus 0 times the integral from 0 to 3 of x squared minus 5 dx. So we get 1/3, and now the antiderivative is x cubed over 3 minus 5x, and we're going to be evaluating that from 0 to 3. And so we get 1/3 times 27 over 3 minus 15 minus 0 minus 0. So we get 1/3 of 9 minus 15, which is negative 6 over 3, or negative 2 for our average value. Now, remember that the mean value theorem of integrals says that there's some f of c such that this is equal to the average value where c is in the interval a to b. So let's go and figure out where that c value is. That's what that's asking us for in part b. So what we're going to do is we're going to set that negative 2, that is our f_av. We're going to go ahead and, so we can set this to c squared minus 5. And this is my f of c value. So to solve this, I have negative 2 is equal to c squared minus 5. So if I add that 5 to both sides, I have that 3 is equal to c squared, which gives me that plus or minus the square root of 3 is equal to c. Now, remember my original interval was 0 to 3, which does not include that negative square root 3 value. So in this case, my c is equal to positive square root of 3 only. And we can check this really quickly. What is f of square root of 3? Well, that is square root of 3 squared minus 5, which is 3 minus 5, which is negative 2, and that is, in fact, our f average. All right, let's take a look at this for the web work problem number 5, which is example 12 here. So we're going to do the exact same thing for this example. First, we're going to find our average value by calculating 1 over 7 minus 1. Those are my a and my b values in that denominator. And then we're going to do the integral from 1 to 7 of 2x to the negative 2 dx. So when we calculate this, we have 1/6, and then the antiderivative of 2x to the negative 2 is 2x to the negative 1 over negative 1, and we're going to evaluate that from 1 to 7. All right, and I'm going to just simplify this just a little bit. So we have 1/6 times, I want to write this as negative 2 over x, evaluated from 1 to 7. So I get 1/6 times negative 2 over 7 minus negative 2 over 1, and that gives me 1/6 times negative 2/7 plus 14/7, which is 1/6 times 12/7, which gives me 2/7 as my average value. Now, what I need to do is I need to find the C value in the interval such that f of c is equal to that average value. So f of c is 2 over c squared. That's my f of c value. And my average value is 2/7. And so if I cross multiply here, I get that 14 is equal to 2c squared, or that 7 is equal to c squared. And then when I take the square root, I get plus or minus the square root of 7 is equal to c. And since our interval that we're looking at is 1 to 7, I know that my c value in this case is only square root of 7. And that is how you do all of the web work problems, 8, 9, and 10 for the end of the 4.4 5.5 web work. And that's going to be the end of this video. We're going to try to keep this one short for you guys. So make sure you ask your instructors if you have any questions. See you next time.